Now, suppose that I then have some material in the space between these two plates of this capacitor that I've set up. What's going to happen is the electric field that exists here, as I put some material in, that's going to cause the charge in the atoms of the material to line up with the electric field. It's going to take some energy to do that, and so as this, whatever's producing this change in potential, delta V, works to pile energy on these two plates, it's also got to do, part of that work has to be done in forcing that charge to move. So it's going to be a little bit different. Let's define that by looking at defining that with some constant kappa. And we'll define kappa as the electric field in free space as the ratio of the electric field in free space to the electric field inside the dielectric. Or I can say that the electric field that would exist in free space is equal to kappa times the electric field inside the dielectric. Now, if I look then at, say, the change in potential between those two plates, if the dielectric fills that space, that's equal to the electric field times the distance, which I can write as the electric field in free space divided by kappa times the distance, which I can write as the change in electric potential that would exist in free space divided by kappa. So, then if I take this in the same way, the capacitance of the capacitor now will be equal to the capacitance of the capacitor with empty space between times kappa. Now, kappa is always going to be, kappa will be 1 for a vacuum and darn close to 1 for air. For other materials, kappa will be above that value. You have a list in the textbook. For Teflon, a dielectric constant of 2.1. For Pyrex glass, a dielectric constant of 4.7. Hey, fill the capacitor with water, it's got a dielectric constant of 80. So by putting material between the plates of the capacitor, thus forcing any charge built up to align, when it creates that electric field has to do work to align these charges. That means that what I've got is that, okay, the capacitance of the capacitor is now higher because of the stuff inside of it. The change in potential is now, for a given amount of charge stored on the capacitor, the change in potential over that capacitor is less than it would be without air. And the electric field inside the capacitor is less than it would be if it were simply in open space.